Alright, so this is section 1.1, linear equations. So in this section we are going to go over how to solve linear equations and equations that lead to linear ones. So in this first part of this section here we have a series of steps to solve linear equations. First step is list any restrictions on the domain of the variable. Well, for these few examples that is not going to make much sense until the next page. Okay, so let's just solve a few examples. A very simple example like this one. So they're asking us to solve 3x minus 5 equals 4. Alright, so our main goal is to isolate the letter x here. And we'll isolate the letter x. So first we are going to add 5 to both sides. Okay, that's going to cancel this 5 with that 5, leaving us with 3x equals 4 plus 5, which is 9. Finally, to get x by itself, we need to do the inverse of this 3 to get rid of the 3. In this case, the 3 and the x are multiplying, so we need to do the inverse of it, which is to divide both sides. Okay, that's going to leave us with, cancel the 3's, we get x equals to 9 divided by 3, that's a 3. Final answer. Alright, let's look at another example. So first one was just a really simple example in which we review the different properties applied when solving equations, which is adding the same quantity to both sides or subtracting depending on the case, and multiplying or dividing the same quantity on both sides. Okay, so what about this one? Well, number one, we have fractions in the denominator. That's the number one thing I see here. So yes, you see parentheses. I know what you might be thinking. Maybe you want to distribute. However, that is not going to be a really good idea, because that's going to lead us to even more fractions, and that's not what we want. Okay, so first of all, we have a fraction times an algebraic expression, another fraction times an algebraic expression. Now look at this negative 4. This negative 4 can be viewed as 4 over 1. Okay, and now that we have this, all the denominators, you might want to highlight all the denominators so you can find at least common denominator. So in this case, we are going to multiply both sides of the equation by a number that divides out both the number 2 and the number 3. That is the product of the 2 in this case, 6 and 6. Alright, so what are we going to do next? We are going to apply the distributive property. I'm going to multiply this 6 with this first term, and then I'm going to multiply the 6 with the second term, and then on the right hand side of the equation I'm going to multiply this. So this is what am I going to get. So when I multiply, okay, keep in mind that when we multiply an integer times a fraction, we only multiply the numerator, the integer, with the numerator of the fraction, okay, not both. So this is what we're going to get. Okay, I'm going to keep the color, so 6 times 1 divided by 2 x plus 5 minus 4 divided by 1, and in this case multiply that by 6. And let that equal 1/3 times 2x minus 1. And in this case, don't forget to multiply with the 6. So this is what are we going to do. We are going to simplify this 6 over 2 That reduces to 3. And we are left. So this 3 times 1 is going to be just a 3 times x plus 5. Minus 6 times 4, which is going to be a 24, divided by 1 is simply 24. And then on the right hand side of the equation, a very similar situation. Cancel out the 6 with the 3 to give us a 2. Right? Now, the fact that we multiply by this 6, that was with the main objective to obtain a new equation with no denominators at all. So that's why we multiply both sides of the equation by the LCD, so we don't end up with any fractions. So now this is going to look a little bit more friendly. So multiply, multiply, same here, distribute by multiplying. Multiply using the distributive property, 3x plus 3 times 5, that's going to give us a 15 minus 24, equals 2 times 2x, that's going to give us 4x, and 2 times negative 1, that's going to give us simply negative 2. Alright, so the next step is, do we have any like terms? Yes, we have this 15 minus 24. If we, you might want to use calculator or anything, I get negative 9 for this, and 3x. Okay, actually I'm going to rewrite this part here. So let me indicate this with an arrow. I'm going here. So this is going to be 3x minus 9 equals 4x minus 2. So now our main goal is to have x's on one side only and constants on the other side. So this is what I'm going to do. I'm going to subtract 4x on both sides. That's going to cancel the 4x's here. And combine 3x minus 4x, that's going to give us negative x minus 9 equals negative 2. The next step I would do, add 9 to both sides. So we get negative x equals, okay, notice how these 9's can go away, and negative 2 plus 9, or 9 minus 2, that's going to give us positive 7. It looks like we are essentially done, but we are not done yet. Keep in mind this negative sign, you can read it as negative 1, so you might want to divide by negative 1 on both sides to get that negative sign and cancel. So x equals 7 divided by negative 1, that's negative 7. Final answer. Okay. Alright, let's flip the page. Let's see what do we have next. Alright, so now, we have one of these equations. At the beginning it's going to look like a quadratic equation, because notice what we are going to have to do. So in this case, we are going to FOIL. So I'm going to do 2 at a time. 2y times y, that's going to give us 2y squared. 2y times negative 1, that's going to give us negative 2y. And then I'm going to do the other part of the FOIL, 1 times y and 1 times negative 1. That's going to be plus y minus 1 equals, let's see what do we do on the other side of the equation. So we are going to multiply as well y times 2y, y times 5, that's going to give us again 2y squared, and y times 5, that's going to be 5y. Alright, now let's do the other part of the FOIL. 5 times 2y, 5 times 5. So 10y. That's going to give us a 10y, and 5 times 5, be careful. Multiply 5 by itself, we get 25. Alright, I know we have a lot of terms here all over the place, so let's see. Number one, my advice here is to combine like terms on either side, actually on both sides of the equation. For example, it looks like we can combine this negative 2y with this 1y to give us negative y, because negative 2 plus 1, that's going to give us negative 1. And just drop this negative 1 and 2y squared. Let's write down the equal sign. Here likewise we can add together the 5y with the 10y, giving us a 15y, and then just drop the 2y squared and the plus 25. Alright, so now the next step here is to have everything on the left hand side of the equation. Alright, send all the variable terms. So this is what I'm going to do. I'm just going to send the variable terms, in this case subtract 2y squared to both sides and subtract 15y. So this is going to cancel these 2y squareds, and this is going to cancel these 15y's. Now we still need to combine, but notice how interesting is this. Also this y squareds cancel, and negative y minus 15y, that's going to give us a total of negative 16y. Keep writing this negative 1. And on the right hand side, the only term that survives is the number 25. Alright, so at the beginning it looked like a scary equation with quadratics. Yes, we're not going to do these quadratic equations in this section, but for sure in the next one. So at the end, this quadratic equation ended up being just a linear equation. So this is one of these equations, ugly looking equations, yes, if you ask me. However, this lead to linear equations. Okay, let's finish solving this. Add 1 to both sides to cancel these ones. So this is going to give us negative 16y equals 26. And the only thing we need to do right now is finally divide both sides by negative 16. Alright, so that's going to give us, going to get these 16s cancelled first of all, and we are going to get negative 26 over 16. Okay, keep in mind that if you have a negative number in a fraction, you can just put it in the front of it. Now we are essentially done. However, we are expected to simplify this fraction to lowest term. So when you do the homework, if you input this as an answer, you are going to get dialog box telling you that although you have the correct answer, is not written in the most simplified form. So we need to simplify this fraction to lowest terms. So notice both numbers are divisible by 2. So I'm going to, because both numbers are even, so I'm going to divide by 2. Alright, so half of 26 is 13, half of 16 is 8. And that's all we can do for this equation. So that was another equation. So an apparently quadratic equation that ended up being a linear equation. Alright, let's look at letter D. So letter D, that even looks uglier. Alright, that looks like an uglier. So in this case, this is going to be one of these equations in which we need to look at restrictions of the domain that we mentioned here in the first step of the previous page. List any restrictions. Why is that? Well, so Notice this equation has the variables in the denominator. So remember that for expressions we can plug in any number for x as long as it doesn't result into a 0 in the denominator. So in this case there is a number here that if we plug in we get a 0 in the denominator, and likewise there is another number that if we plug it in here we get a 0 in the denominator. Okay, so how are we going to deal with those restrictions? So let me highlight those potential zeros in the denominator. This is one and this is the other one. Alright, so and let me write this with red. So restrictions. So number one, x minus 2 cannot be 0, or x minus 1 cannot be 0. If we solve this mini kind of equations looking at to the both sides, so x cannot be 2 or x cannot be 1. So these are our restrictions. Okay, keep this in mind. Alright, so these are our restrictions. What happens if you plug in 2 in the denominator of the first term? Okay, 2 minus 2, you get a 0 in the denominator. 3 divided by 0, that's undefined, and that's not what we want. Likewise, if you plug in the number x equals 1 in the denominator of this term, you get 1 minus 1, which results into a 0 in the denominator, and that's not what we want either. Alright, so I guess I will have to rewrite the equation for space restrictions. Okay, so what are we going to do here? So now we want to get rid of the denominators, right? How are we going to do? In a very similar way we did in the previous example, by multiplying by the LCD. So what is the LCD going to be? Okay, LCD. The LCD, which is the least common denominator, will be the algebraic expression that divides out all the denominators. In this case, the product of these two, x minus 1, x minus 2. So I'm going to multiply both sides by that quantity, x minus 1, x minus 2. Okay, and what are we going to do next? Well, I'm going to multiply the product of these two algebraic expressions with the numerator of the first fraction. I'm going to go to the right hand side. I'm going to multiply this with the 1 right here, and I'm going to multiply this with a 7. Alright, so I'm going to keep the same colors just so you can see what am I doing. So this is going to be 3 times the quantity in green that I'm going to distribute, which is x minus 1 times x minus 2. And that's going to be divided by x minus 2. Okay, equals 1 times the product of these two. That's going to give us 1 times the product of x minus 1 times x minus 2. Divide that by x minus 1. Okay, I'm going to keep parentheses even though we don't need parentheses here or parentheses there, just so it looks like what I am about to cancel. Okay, let's do the last part of the distribution, which is going to be plus 7 times the product of these two quantities in green, which is x minus 1, x minus 2. And then divide that by x minus 1 times x minus 2. Okay, so we have just distributed these factors right here. Now it's time to cancel or divide out common factors. So cancel the x minus 2. So rather than doing foiling here, that's not going to lead anywhere. Divide out these two, divide out these two, divide out these x minus 2's, divide out these x minus 1's. So what are we going to be left with? We're going to be left with 3 times the quantity x minus 1 equals 1 times x minus 2, which is simply x minus 2. I'm going to keep the parentheses, then I'm going to get rid of them. And then the number 7, simply the number 7. Alright, what am I going to do next? So the next thing we do is distribute the 3. And think of this as having an invisible 1, so you might want to distribute that 1. But ultimately what we do is simply get rid of the parentheses for this. So I'm going to have 3x minus 3 equals x minus 2 plus 7. Before moving things around, let's first of all combine like terms. 7 minus 2, that's going to give us a 5. And still we get 3x minus 3 on the left hand side. Alright, so now let's have the constants on one side and the variables on one side. Does it matter which one do we do first? No, it doesn't matter. I can add 3 to both sides first, have the constants on the right hand side, and then subtract x to have all the x's on the left hand side. Or we can subtract x first on both sides and then add 3 to both sides. Doesn't matter the order. So I'm going to do the x's first, alright? But again, if you want to do it the other way, you should get the same thing. Okay, so that's going to give us, that's going to cancel the x's here for us. And 3x minus x, that's 2x minus 3 equals 5. Add 3 to both sides. That's going to lead to 2x equals 8. And finally, divide both sides by 2 to get this 2 cancel. By the way, cancel these 3's. And divide 8 by 2. So that's going to give us x equals to 4. Now, we need to be very, very careful with this type of equations because, again, we have restrictions here. So x can never be 2, nor x cannot be positive 1. So, is our final solution x equals 4? Any of these restrictions right here? In this case, when we compare, it turns out that it is not one of the restrictions. So, this is a legitimate solution. This is a good solution. Are there any situations in which it's not going to work? Well, let's find out. Let's look at the next example. The next example, it is very similar. Okay, number 1, observe how the denominators have variables. Okay, so let me highlight the part. In this case, I'm using the same color because it's the same denominator. So that's the term, or rather the factor causing trouble in this case. So let me write down the restrictions. Okay, so the restrictions are that x minus 1 cannot be 0. In other words, x cannot be positive 1. So that is going to be our only restriction. Alright. Okay, let's get ready to move on with this example. So now we need to get rid of these denominators by, again, what did we do on the previous examples? Yes, multiply both sides by the least common denominator. However, before we do that, keep in mind that this 2 is a 2 divided by 1. That way this looks like we have denominators Okay, so we are going to multiply by the LCD, which in this case is simply x minus 1. In this case, we don't have more than one different factor, so just like we did on the previous example, so this is enough. Okay, so we multiply both sides by x minus 1. Okay, so let's see, let's do the distribution. Multiply the 3x I have in blue times x minus 1. Okay, 3x times x minus 1 divided by x minus 1 plus 2 times x minus 1, which is equal to the quantity 3 times x minus 1 divided by x minus 1. Alright, so this is time to divide out common factors right here, right there, and distribute the 2 along the parentheses. Alright, so in the first term we are just going to be left with the quantity 3x. Over here we are going to obtain 2 times x, which is 2x, 2 times negative 1, which is negative 2, equals 3. So let's combine like terms. 3x plus 2x, that's a 5x, minus 2 equals to 3. And then what do we do next? Add 2 to both sides to get the 2's cancelled. That's going to leave us a 5x equals 3 plus 2, which is 5. And finally, divide both sides by 5 to get x equals 1. Okay, so this is the potential solution. But again, like we did in the previous example, we compared whether x equals 1 is one of the restriction, and it turns out in this case this is the restricted value. So in this case, no solution, even though algebraically made sense. However, in this case turns out being the restricted value, so no solution. Alright, no solution for this one. For the last example of this section 1.1, we have our problem. Okay, so we have the perimeter of a rectangle, which is 42 meters. They're asking us to find the length and the width of when the length is twice the width. Alright, the best thing to do here when it comes to word problems is to draw a picture. Okay, let's draw a picture for this. So first of all, we have a rectangle. Alright, we have a rectangle. Rectangle has a length and has a width. Okay, we don't know any of it. Okay, we don't know any of it. Alright, but we know that the perimeter is 42. Okay, so that means P equals 42. Number one, it would be a good idea to recall the formula to find the perimeter of a rectangle. So the perimeter of a rectangle is twice the length plus twice the width. Okay, so now let's represent this length and width in terms of one single variable, because in this case, if we put the numerical value, we are going to end up with one equation and two unknowns, and that's not going to lead to an easy problem to solve. So in this case, well, let's focus on this part of the problem in which it says the length is twice the width. Okay, so we don't know anything about the width. We can just call it x. So in this case, this is twice the width, the length is twice the width, which is 2x. Okay, so in summary, the width equals x and the length equals 2x, which we can safely plug in here and there where they correspond. So now let's go here. 42 equals 2 times the length, which is 2x, plus 2 times the width, which is simply x. Okay, so if we multiply these two, we're going to get 42 equals 4x plus 2x. 4x plus 2x, that's going to give us a total of 6x equals 42. If you want to reverse the equation in a way that you read the variable on the left and the constant term on the right hand side, that's the best. That's what I would do, so it's easier to read. That is very important. It will be very important later in the chapter when we go over inequalities. So I'm gonna do here, I'm not really doing anything interesting other than reversing the order of the equation. So all we do is divide both sides by 6. So that's gonna give us, that's gonna get the 6's canceled. So x equals 42 over 6, which is 7. However, don't forget that we are having now some sense of application. So keep the units. Okay. So this is the value of x. All right. This is the value of x. We are not done yet with the problem. We need to go back to our setup to answer the question. So this is going to be 7 meters. And this is 2 times 7 meters, which is 14 meters. Alright. And in this case, notice 14 is twice 7, so this condition is met. The length is twice the width. Alright, so this is the end of this video. I will see you on the next section, section 1.2.